This is part 2 of the interview with Dave Tomlinson. So the system itself, why don't you talk us through how our traffic management system works? For example, if I'm downloading an application and using peer-to-peer, how does it work?
Okay, we've got a database of pretty much anything that you can do on the internet. List virtually every type of traffic that there is, almost every game, peer-to-peer application, VPN, anything you can think of is pretty much in that database. There's a few things missing, and as new games come out and new apps, we add them in. So it's an ongoing exercise to make sure that's as up to date as can possibly be. And from that database, what the systems do is they have a look at what you're doing and tries to match what you're doing with something in that database. And it does that using a combination of different techniques. It might be that it looks at what port your traffic is on. So if you're using port 80, it'll say, okay, chances are that's going to be HTTP. I'll see if I can match that against HTTP. If you're using port 110, it suspects it's likely POP3 email, and it goes and checks that. If you're using 6881, this is one of the default ports for BitTorrent, it goes and has a look and see if it matches BitTorrent. So it does that and matches your traffic against the database.
So it's not just the port, it's additional checks as well,
yeah? Yeah, so it depends on exactly on the traffic. So it might be if you're using something like TeamSpeak, which is a VoIP application, a lot of people run that on lots and lots of different ports. Simply because you can have one TeamSpeak server and which can have a dozen ports on it. So it doesn't matter what port it's on. And we look at that and say, okay, that's TeamSpeak. It doesn't matter what port that's running on, we can pick that up. Well, it just makes it easier because you're going to say 99% of traffic on port 110 is going to be email. So it says, right, is it email? Yes. It doesn't need to go and do the extra checks. Whereas it'll say, well, is it port 10? Is it email? No. Then it'll go and scan. Oh, it's something else. It's someone running a site on port 110, like webmail on POP3 or something daft.
Yeah.
So it does that and looks at what type of traffic it is. From there, it then allocates a priority. So it looks at what type of account you're on and says, okay, you're on a Broadband Your Way option 3 account, you're doing peer-to-peer, we'll give that silver priority. We'll give that, it's not the lowest priority on the network, but it's not the highest. It might be if you're on Pro, it'll give you gold, it'll give you a higher priority.
Yeah.
So from there, it knows what priority to give that, and it'll look at the time of day it is and says, do we need to apply any rate limits to that traffic? So again, appropriate to your account type. So if you're on Your Way option 2 when it's in the middle of the day, it's in 2 o'clock in the afternoon, there might be I can't remember exact rate limits offhand, but it might be 128k rate limit or whatever it is at that time, and it applies that. Then from there, we take the traffic and aggregate it before sending it down to you. So it goes across our central pipes, and so long as the amount of traffic going through our central pipes is less than the amount of traffic that's trying to be downloaded is less than the amount it can take, everything will go through fine. There is a point though where there might be more traffic going through the pipes than the pipe can actually transfer. So at that point it'll do one of two things. It'll look at the priority of the traffic and say, where should that go? So your high priority traffic, your VoIP and your gaming, that all goes through, nothing affected, that goes through without it doing anything to it.
Yep.
Then it'll say, okay, what have we got left? And we set a set of weightings so that a certain amount of gold traffic will go through, a certain amount of silver and a certain amount of bronze. And so we'll let each of those through. And if the amount of gold going through is less than how we've allowed it, that the extra allocation goes to silver, and then that goes to bronze.
Yeah.
So you get through, and by the time you get down to bronze, there isn't enough left, it'll then buffer some of the bronze traffic and try it again in a few milliseconds. And if it still can't drop it through after a few seconds, it'll drop that traffic and it'll get retransmitted a bit later. And it'll do that the same as the network increases, the more bandwidth, it'll do the same on bronze, then it'll do to silver, and eventually it'll do it to gold. That's kind of like the network is really busy when it's starting to buffer the gold and eventually drop the gold. That's one of our metrics for measuring is, does it drop any gold? And our aim is for 0 gold drops.
If we ever see gold drops, that's a point where we know we have to take a look at the network capacity and make sure everything's working.
Yeah. Sometimes there's some reasons why it will drop gold traffic. For example, you can't manage the entire network in one go. You've got to do it on each 622 pipe.
Yeah.
So it might be that one 622's got plenty of capacity spare, and another one's got lots of customers on it, and it's starting to drop starting to drop traffic because it's really busy compared to the other one. We've had that recently where we've gone into high demand operation because 2 events happened at the same time. We lost one 622 pipe, it dropped all the customers on it, and they all reconnected across the other 6 gateways, which meant that they were all really busy, and that one was really, really low on customer numbers. And then that same evening was a Microsoft Patch Tuesday, which from historical, we know that Microsoft Patch Tuesday is usually the busiest day of the month because everyone starts downloading the patches up in the evening about 6 o'clock. The patches will start going down. There's an extra 200-300 meg of traffic on the network. So we put the network into high demand because those 2 things happened at the same time. If there was only one of them, it would have been fine.
Yeah.
But both of them at the same time meant that it went into high demand. And we saw some gold drops on the other gateways. The one without the less customers on was fine. The gold drops are on the others.
When you say high demand, what does that mean? High demand mode?
High demand mode, it's a way of us changing how the network works. In this particular case, what we did was we adjusted the weightings on traffic. As I said, with the weightings on gold, we increased that to allow more gold traffic to go through, and we dropped down the weighting on the peer-to-peer and Usenet. So that in that evening, anyone who was downloading from peer-to-peer and Usenet might have seen slightly slower speeds on those other gateways in order to make sure that the gold traffic was unaffected. Mm-hmm. So if you were browsing the web, checking your email, VPN, you shouldn't really have noticed much of an impact. You might have noticed a little bit, but it would have been a lot worse had we not made that change.
Yeah.
And then the Wednesday night, it was starting to get back in balance, and it would have been a lot better. So the high demand in this case adjusted the way the network works to just give everything a better performance. And had it not been needed, then the network would have performed as normal. Mm-hmm. So the way the high demand works is that if there hadn't been that extra gold traffic in that bit, then that spare capacity would have been given over to the bronze, so it would have still had the same performance that it would have had we not made that change.
We communicated out with our service status tool when we were going into that high demand.
Yeah. We put a status alert out that evening that the change was going to be made, and we made another update further in the week. I'm probably going to make another one. By the people who've seen this, it'll have already gone out, but in the next day or 2.
Okay. So a day in the life of Tomo then. Obviously you look at all of this, but why don't you just take us through an example of the sort of thing you do?
Okay. There's a lot of things that I try and cram into any particular day. Usually I work roughly 12 midday to 9 p.m. Give or take an hour, might move it around, but that allows me to be in when most people are online and using their connections. I can monitor the network real time when it's busiest. So that's first thing that sets me apart from most of the rest of the business, is that I'm working slightly different hours. Usually when I come in, the first thing I'll do is check the graphs and check the network performance for the previous evening, see what happened. Did we get things right? Were things wrong? Did anything happen? Has there been any problems? Did any of the pipes drop? Has there been any gold drops? Check all the latency, check all the metrics and see how everything performed, see how many people are online, and just match it all up. And then look for any patterns, see if there's anything like, oh yeah, a massive download of something. I mean, today we've got Vista Service Pack 1 came out yesterday evening, and there's a couple of big patches come out from Apple as well today as well. So we're expecting those to have a big impact on the amount of traffic. There was a spike last night on the HTTP downloads from people downloading Vista SP1, and probably more tonight with the rest of the patches being downloaded. So we look at things like that. So that's kind of the first thing. And then I'll generate a load of data and put all that in from Management information systems, we've got a big SQL database which contains usage data about all the customers and exactly what they did. So when you look at VMBU, the VMware usage tool on the portal, you see the split on there of the different types of traffic and how much each customer is used. What AMIS does is gets that for every single customer and puts it into a big report so I can see, or anyone else in the business can see, exactly what's going on the network. So we can look at that and see how the network performed in finer detail and compare it with different days and see what the trends are. So we can look at, like the streaming usage in iPlayer, look at how that's increased over the past 2 months and see which customers it's increasing for. So in this case, it's all different types of customers and all different times of day. So we can analyze that data and see how that goes.
Yes, that's the key to the traffic management proposal, really, isn't it? You have to keep looking because it's always changing.
Yeah.
And I think you started doing this about a year ago now, and before then it was kind of a mixed role by our networks department and our comms team, etc.
Yeah.
I think now we seem to have a much better focus on it. Do you think?
I think so. Yeah. I mean, the approach perhaps wasn't completely joined up. There was products would look after the overall, and the networks would have their part, and the comms team. Whereas I'm kind of like joining them all together. So my job is within the products team, but I'll spend some of my time of the day with the CSC and with the comms team because they're in the evening and products team aren't. So I'll spend time with them, and I can see what the customer support centre, the CSC, are getting, what type of calls they're getting. So if they're getting calls from people with speed faults or where there's problems on the network, I can be there and react to what they're saying and help them out or make changes on the network as necessary.
So you can actually change how the network's performing. If an event happens, which means we have to change the way those waitings work, you can do that.
Yes. So if, for example, if we dropped a central pipe and we lost it didn't come back up, I could go in and make a change on the network so that, for example, I could reduce all peer-to-peer speed to 64 kilobits, for example. Obviously, we put out Siri status and communicate what we're doing, but we can react to that and do it and make that change so that the impact of that loss isn't as big as otherwise it might be.
Because in that scenario, if we didn't do that, all VoIP traffic would stop working. Your games would start being laggy, web browsing would time out, all of those interactive things would start really suffering, wouldn't they?
So you'd have 100,000 customers would be experiencing problems, but we can make it so that just those that are just downloading something by peer-to-peer would see it slow down, the rest would still work. Obviously you might not have the same speeds on your speed test and your file downloads might not be as fast, but for general speaking, for most people, we can make it so that they're not affected by a major problem like that.
And that's an emergency situation as well, isn't it?
It's
not something we expect to happen very often.
It's not something we expect at all, but we've got to be prepared for it and be able to react to it and make that change. There was recently a situation where BT needed to do some maintenance work on 2 of our central pipes, and there was a danger that the pipes weren't going to be back online by the time business users would start to come online at 8 AM. It was a very small chance, but it was a real possibility. So we had to have on standby a configuration that would rate limit all traffic to, I think it was 1 meg, and block all peer-to-peer and Usenet. It was a real standby just in case this is doomsday scenario, because these 2 central pipes might not come back in time. But we had that on standby and we could have done that if needed. Fortunately, we didn't. Maintenance was fine, it all came back and everything worked okay. But it's that kind of situation where we're able to react and plan and have things on standby just in case they are needed.
Okay. So the future then, where are we going with our traffic management platform? What are we working on?
Well, there's always an ongoing part of putting new applications into the database. Again, it's going back to what I do on a daily basis is customers will raise to us tickets on new games or application that they find isn't working or isn't being picked up correctly. So we'll review those and add those in as and when. We're also proactive with that as well. So if we know a new game's coming out, we know Mario Kart Wii is coming out soon. So we want to try and make sure those games, where we can, get them in place in the database so they're picked up for the day release. So when the customers go out and buy the game, they don't find that it doesn't work on PlusNet. We want to make sure that it's working.
Yeah.
But say with however many dozen games and applications that come out every week, there'll always be some that we'll miss. And there will always be cases where we can't always add them in time for the release dates.
Mm-hmm.
But where we can, we will. So that's the first part of the traffic management going forward. From there, we've also going to develop how everything works. At the moment, a lot of things that we do are manual. For example, when it looks at how busy the network is and what rate limits to apply, it doesn't automatically change those. Let me explain a bit what I mean. Is on a Friday night and a Saturday night, for example, our network is a lot quieter. People go out and aren't online. So we can generally increase the rate limits on things like peer-to-peer and using it in an evening on Friday and Saturday. But that has to be a manual change.
Right.
We've got to plan for it. So we know Saturday we'll make the peer-to-peer faster. But if we don't get it right, we could have made it a bit higher. Because if more people are out, there'll be more spare capacity.
Mm-hmm.
We're going to make that so that's done more intelligently and more automatically by the system.
So the limit on peer-to-peer will relax as the traffic frees up, I guess.
Yeah. So at the moment it'll step up as we predict and say, okay, at 8 o'clock there's going to be that amount of spare capacity. At 9 o'clock there's going to be that. But if we get it so that it, instead of doing like that to like that, it'll do it like that. So it'll curve it up itself. Mm. So that's one thing that we've got in the planning for just the way the platform works. We can also going to do more intelligent work on how it picks up different types of traffic. There's new hardware out there from Melicoya that we've been looking at that can do better deep packet inspection, and so there's less chance of it picking up traffic incorrectly. Mm-hmm. So at the moment there are possibilities of it picking up one type of traffic as another. Sometimes people will say, well, why isn't my gaming showing as gaming, or why is my peer-to-peer showing up as other, or something like that. Mm-hmm. It's just small amounts of traffic it'll get wrong, just because there's just so much different traffic out there. It's not easy to make a mistake, but it can sometimes make a misidentification of just little bits of traffic, and you'll see just little bits to say, why have I got a bit of FTP? Why have I got 50 bytes of FTP in my traffic? Yeah. It's just picking it up and identifying it as FTP, perhaps because someone's pinging or probing you, but you can do more different way of analysing that.
Okay. All right. I think that's it then for the moment. Thank you very much for watching this. I hope you enjoyed that and found it interesting and provided you with some good information about how your connectivity works. If you want to learn more about this, have a look at our community site, community.plus.net, and take a look at the blogs that Tomo produces quite regularly. Absolutely packed full with really great information, and it should help you really understand a lot of this stuff. Thanks for watching.